So here I've got a final exam for 1103, which is a pre-calc class in California. So let's do it. Find the equation of a line that's parallel. That shouldn't bother, but maybe one of you. We're going to shift the 5y over. 2x equals a negative 5y plus an 8. I don't know why I'm doing that. Apparently I need to wake up this morning. We're going to shift the 2x over. 5y equals negative 2x plus 8. Divide by the 5. And this is my slope. We're going to be parallel, so the same. So gone. Gone, gone. It's going to be d or e, right? Anyways, my slope is negative 2/5. I pass through this point, which is oddly enough. I mean, you could literally do y equals mx plus b on this thing. You see it? Yeah. Oddly enough, it doesn't seem to be right. Anyways, we'll just use point slope form. Y minus y1 equals m times x minus x1. So y minus 0 equals the slope, negative 2/5, of x minus a negative 1. And, you know, that's going to be plus plus, and it's going to be negative, so we got to be choice E. Find the domain. So for the square root of anything, so long as it's above 1, what's inside, or sorry, not 1, but as long as it's not above an expression of x, anyways, what's inside must be greater than or equal to 0. So 4 minus x greater than or equal to 0. Shift over, negative x greater than or equal to negative 4, divide by the negativity, and x is less than or equal to 4. We have the equality, so I'm looking at my brackets, choice D. So this is something that bothered a couple of y'all when you were doing the practice thing online. This is a plus h, which is pretty common. It's actually what I learned. But anyways, we're going to let every x we see be a plus h. And if I'm going to square it, I'm going to write it twice. And we're supposed to take away the original function. And it's all over an h. There's your setup, okay? So I'm going to work on this off to the side. I'm going to have a squared plus ah plus h squared, which is a squared plus 2ah plus h squared. And now there's a 2 out in front, so I'm going to double it. I'll have 2a squared plus 4ah plus 2h squared. 2a squared plus 4ah plus 2h squared. Distributive property, minus 3a minus 3h. Distributive property. This is f of a, isn't it? So these need to be FMAs. Minus 2a squared plus 6a. And it's all over h. So moving forward with my life, I should have some things cancel. Like here's a positive 2a squared, and here's a negative 2a squared. Here's a plus 6ah. I don't know why I'm saying plus 6, it's plus 3. Negative times negative positive. Plus 3a and a minus 3a. And that looks like everything that cancels. So what do I have left? I have 4ah plus 2h squared minus 3h, and it's all over an h. And some h's are going to cancel. Makes that a 1, gone. And I have 4a plus 2h minus 3. Looks like choice E. Not a hard problem. All right, what do we have here? Find f of negative 1 plus f of 4 given this function. So we have a piecewise function. This is the line you get to plug f of negative 1 in because it says less than 1. And I think you get a 2 back. And the other one is f of 4, which is where this one has to go because greater than 1. So f of 4 is 3 times 4 minus 1, which is 11. And I want the addition, add them together, 13. Ta-da! All right, moving on to 5. The graph of the function y equals f of x is given below. Select the answer choice that represents the graph of f of x plus 2 minus 1. So all we're looking for here is a left shift 2 and a downshift 1. That's all I'm looking for. So something that makes it go left 2 and down 1. I think this is the winner. Because if I take 1 and I subtract 1, I get 0. If I take negative 1 and I shift it left, I get 3. So yeah, it's choice B. Easy peasy, Japanesey. Just making sure the other points hold on. Negative 4 minus 1 is negative 5. 3 minus 2 is 1. Negative 3 minus 2 is negative 5. Negative 2 minus 1, yeah. Choice B checks out. All right, which of the following functions has an inverse function on the domain of negative infinity to positive infinity? Well, let's talk about the ones that actually have inverses. And there's things we know. Like this guy, t to the fourth, is a parabola. It has no inverse. Not unless you restrict it. If you did, remember we would take half of it? It would be something along the lines of x greater than or equal to 0. So its domain would be 0 to infinity. Sine of t, I mean, we know these things. We know this thing goes on and on and on and on and forever. It has no proper inverse. And in fact, when we talk about the domain of the arc sine of something, that's valid in only what quadrants? 1 and 4? That's negative 90 degrees to theta to 90 degrees. So obviously not that. It's the line, because that's a line. The inverse of a line is a line. It's choice 2 only. What do we got next? If 2, negative 5 is a point on the graph of f of x, which of the following points must be on the graph of 1/2 of x minus 1? Or 1/3, sorry. Let's do this first. This divides y by 3. So we're going to take our point and we're going to divide the y value by 3. This adds 1 to x, 3 negative 5/3. Choice E. All right, number 8, find the inverse. All right, first rule on inverse is we swap x and y. So this becomes x, and it would be 2 over 3y plus 1. Now what we would do is we would 3y plus 1 both sides. Just 3yx plus x is 2. Well, this was a pretty easy one, isn't it? We'll shift that one over. 3yx equals 2 minus x. And we'll divide by 3x. And this is what I'm looking for. 2 minus x over 3x. Choice B. The vertex of a parabola given by the equation h of x is kx squared minus x plus 1, where k is a positive constant, is well, this is just legit opposite b over 2a. The vertex is at opposite b over twice a. So b is a negative 1, and a is k. So if I plug in a negative 1, I get a positive 1 over twice k. So I'm looking for 1 over 2k. So I'm going to scratch out D. It might still be E. Now to find the y-coordinate, I should say x-coordinate vertex, to find the y-coordinate, plug in. So h of 1 over 2k is 1 over 2k, sorry, k times 1 over 2k squared minus 1 over 2k plus 1. So if I square this, I get 1/4 k squared. There's k out front still. And the k's cancel. I'm looking for something that says 1/4 k minus 1/2 k. Okay, so there's still more to do here. 1/4 minus 1/2 is negative 1/4. So this becomes negative 1/4 k plus 1. Choice C. 10 is probably where I'll stop because I might do a couple more. Given that x equals negative 1 is a zero of this polynomial, what are the sums of the other zeros? So we'll do good old synthetic division, reduce it down to a quadratic. Maybe it'll factor. And that's what we'll do. Notice the gap here. So we got a 16, a 0, a negative 13, and a 3. And we're going to synthetically divide out the negative 1. We drop, we multiply, and we add. We multiply, and we add. We multiply, and we add. And it's been a while since I've done this with y'all, but there you go. Remainder constant xx squared. We have 16x squared minus 16x plus 3. We're going to try to factor it. I think it factors. I think it factors quite nicely. 4x and 4x minus 3 and minus 1, because the inside is going to make negative 12 and the outside is going to make negative 4, looking for negative 16. So 4x minus 3 equals 0, or 4x minus 1 equals 0. So x is going to be 3/4, or x is going to be 1/4. And I want the sum of the other zeros. So 3/4 plus 1/4 is 1. Perfect. You guys ought to do really good on problems like that. Find the inverse of this function. All right. Again, we'll do our swapperoonie. X is 2 to the y plus 2. This is a base. This is an exponent, which means that this is my answer. And I'm doing the whole log is bay idea. So my base is going to be 2. I'm a log base 2. My argument is x, and I equal y plus 2. And all I got to do is shift that over. That makes her negative. Go. Find the range of this function, g of x equals e to the x minus a plus b, where a and b are some positive integers. Ugh. So this is right a units, and this is up b. This is a vertical reflection. Now you guys were supposed to memorize y equals ab to the x, which is something like that. All right. This one has been shifted up b units, and it's been shifted right a units. The shift right actually doesn't affect anything, and it's just never going to hit that horizontal asymptote. So the range is going to be ridiculously close to b and rising to infinity. All right, now we got a question about Bob the builder, because he's making something. Bob is making a rectangular garden next to his home. He has 100 foot of fencing and plans to use the side of the home as side of the garden. Assume the width of the garden is W. Write the area of the garden A as a function of W. Remember, area is length times width, all right? If I have 100 feet of gardening, a fence, and there's 2 widths that I'm using, this length right here would simply be 100 minus twice W. And then I'm just going to plug in. My length is 100 minus twice W, and my width is W. And then I'm going to do the old distributive property. if I need to. And I don't, because it's that one. Didn't even have to finish the distributive property. Perfect. Find the domain of the following function. You may or may not remember where I had you push buttons in the calculator and figure out what you couldn't be, but the domain of a log with anything in it is that anything in it must be bigger than 0. So x minus 1 is bigger than 0, x is bigger than 1, 1 to infinity. If f of x is 1 plus 1 over x and g of x is x minus 1, find f composed of g of x. So we're going to take this and we're going to put it there. This becomes 1 plus 1 over x minus 1, which is not an answer choice. So what we're going to do is we're going to kind of do like a little butterfly here. We're going to give this one x minus 1. There's a plus, so a plus, 1 times 1, and the unified denominator is 1 times x minus 1. Now doing the distributive property and cleaning things up, we would have x over x minus 1, choice A. The remainder r when blah 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 is divided by x plus 1 is what are the following. Here's what you can do. Instead of synthetic division, plug the x value in. So remember, if x plus 1 is a 0, then x is negative 1. So I'm going to have 20 times a negative 1 to the 30th minus 4 times a negative 1 cubed plus a negative 1 squared minus 3 times a negative 1 plus 2. Now, if I take negative 1 and multiply it by an even, it times itself an even number of times, I just get 1. A negative times a negative times a negative is still negative, but a negative times a positive is, well, we would just leave it there. That's going to be 1 plus 3 plus 2. So I've got 20 plus 4, and so far I've got 6 over here. This is 30. And the last one I'm going to do, and then I'm going to stop so I can get ready for my next class. If f of x equals 1 plus 1 over x and g of x is x plus 1, find f over g. It's literally f divided by g. It's 1 plus 1 over x divided by x plus 1, which is not going to be an answer choice. It's just not going to happen. So what should we do? What should we do? We should probably clean this up. 1 times x plus 1 times 1, 730 over x, all over x plus 1. It's supposed to be 1 times 1. And this cleans up to be x plus 1 over x. It's all over x plus 1. Maybe you remember this, maybe you don't. Remember, that guy's under an understood 1. And to divide by a fraction, you multiply by the reciprocal. So this becomes x plus 1 over x times 1 over x plus 1. Really interesting what happens there. Done. And that's where I stop for now. I'll probably finish the rest of this during my planning period today. If not today, I'll finish it all tomorrow morning.